Today we're going to review what a median is. In order to understand today's lesson, you must know how to find the median of a set of data. Find the median of each data set. So median means middle. So notice our data sets are all ordered. We need to find the middle. So I see 1, 2, 3, 4, 5, 6, 7 numbers. So the middle of 7 is going to be 3.5. 1, 2, 3. And then if I go count from the back, 1, 2, 3. So technically 14 is in the middle. And then I turn it into a little belt. Okay, so then we have the belt buckle on the other side of the belt. So our median is 14. Number 2, 1, 2, 3, 4, 5, 6, 7, 8 numbers. So the middle of 8 is 4. So count from the front, 1, 2, 3, 4. From the back, 1, 2, 3, 4. So the middle is going to be between 40 and 90. So again, draw your belt. So we have to do some calculating. We have to figure out what is the average of 40 and 90. So we're doing 40 plus 90 divided by 2, and you get 65. Number 3, 1, 2, 3, 4, 5, 6 numbers. So the middle of 6 is 3, so 3 from the back and 3 from the front is going to put me here. So if I average 60 and 60 together, I'm just going to get 60. So that is how you find the median. Today we're doing box and whisker plots. So when you do a box and whisker plot, you have quartiles, values that split each data set into 4 equal parts. Every set of data can be broken up into 4 equal parts. The median is the second quartile. It separates the data into 2 equal halves. The first quartile is the median of the first half, and the third quartile is the median of the second half. The interquartile range is the difference between quartile 3 and quartile 1. And we'll go through an example with all of these. So 5 important data set values. You have your whisker, so your min, and then your other whisker will be at your max. And you have your quartile 1, your quartile 2, and your quartile 3. So this would be the middle part of your data. This is where you have your belt. And again, you have your belt. And then you have to find the middle of your 2 belts. So then here's the middle, and here's the middle. So that's where our quartiles fall. Determine the min, quartile 1, quartile 2, quartile 3, and a max of the data. So this is an odd number of numbers. So the first thing we need to do is get them ordered. So once you get your numbers ordered, I'm just going to double check. I'm going to count to see how many numbers I have. I counted 11. Double check that I have 11 in my new list. So to make a box and whisker plot, you need to find the median. So the median of 11 will be 5.5. 1, 2, 3, 4, 5.5. 1, 2, 3, 4, 5.5. So 85 is our middle. So when we have an odd number of numbers, we actually have a number that will make our belt buckle. So now we need to find the medians of our 2 belts. So I have 1, 2, 3, 4, 5. It's going to be the third number. So this is our Q1, this is our Q2, Q3, and then this is our min, and this is our max. So you want to get your number line set up. I saw our min was 60, our max was 105, so I counted by 5. I have 60, 65, 70, and so on. Then I put my red dots at all of my identifiers, min, Q1, Q2, Q3, and max. And then I made my straight line, and then I made my box. So then I have my whiskers and my box. So what happens in our picture is we get the data to spread out here. So in this section, this is a fourth of the data, this is a fourth of the data, this is a fourth of the data, and this is also a fourth. So inside the box we have half of the data, and then on both of our whiskers combined we have half of the data. Let's look at another example. Here's an even number of data values. So again, I ordered them already. So we need to find the median. First we'll count our numbers. I see 6 numbers, so the middle of 6 is going to be 3. So this is what my belt would look like. Now we need to find our quartile 1 and quartile 3. So the middle of the front belt and the middle of the back belt are found. And my whiskers are 5 and 53, or my min and my max. So I'm not going to draw a box and whisker on this one. There's just not enough data for it to be very valuable. Vocabulary. Box and whisker plot summarizes a set of data by using the median, minimum, and maximum displayed along a number line. So always notice that your box and whisker has to be on a number line. The left whisker extends from the min to the quartile 1, and it represents 25% of the data. The box extends from Q1 to Q3, and that represents 50% of the data. And then the right whisker is Q3 to the max, which is also a fourth of the data. So we need to be able to make box and whisker plots. So here's some data. The table shows the amount of crops harvested for a certain period of time. So in year 0, this is how many acres, year 1, acres, year 2, and so on. So here's that same data set. We need to order so we can find our quartiles. So here are my numbers ordered. I notice I have 11 of them, so the middle of 11 is going to be between 5 and 6. So 1, 2, 3, 4, 5, 1, 2, 3, 4, 5. So this number here is in the middle, and then I can draw my 2 belts. So I need to find the middle of each belt. So I see 311 and 316. Once I add my data points and I draw my line and my boxes, this is what my box and whisker would look like. So notice our box is pretty tight, so that means that our data is pretty spread out on our whiskers, but we have a lot of data that happens in that box, because remember that's 50% of the data, and then our whiskers also carry 50% of that data. Here's the book solution. Are the years included in the box and whisker plot? No, only the acres are included. Number 2, why is it important to use a real number line? Each section shows 25% of the data. The length on the box and whisker plot shows us how much data is in each section so that we can compare the distribution. Number 3, because the whiskers are relatively long and the box is relatively compact, what is indicated by the distribution of the data? That the data points are going to be close together in that box, and there will be some outliers on the whiskers. And an outlier is something that isn't comparative to the rest of the data. Use the box and whisker plots below. What do they tell you about fuel efficiency for each type of vehicle? So on the top we have cars, and on the bottom we have trucks. Notice that the box for the cars is farther ahead than for the trucks, and the whiskers on the car are a lot longer than on the truck. So what do we know about the vehicle? So I said trucks have more consistent miles per gallon, whereas a car can have more variation in their miles per gallon. You could buy a big car, a small car, a really small car, a hybrid car, but with a truck you're pretty much stuck with something that's about 15 miles to the gallon. Why don't you try this one? When I calculated my medians, I had to calculate the average of all 3 quartiles. So I averaged 70 and 90 and got 80, 120 and 220 and got 170, 224 and 280 and got 252. And then I plot my points on my box and whisker and look at my spread. The second question asks which portion of a box and whisker plot represents the interquartile range. So that would be quartile 3 minus quartile 1. The last thing we're going to look at today are two-way frequency tables. Statisticians use two-way frequency tables to examine the relationship between two categorical variables. Entries in the table contain frequency counts. The following two-way table shows the favorite leisure activities for 30 adults, 20 men, and 30 women. So there's 2 men that like dance, 10 men that like sports, 8 that like TV, so our total of men is 20. For women, 16 like dance, 6 like sports, 8 like TV, for a total of 30. So then look at our total down here. We have a total of 50 people participating, 30 women and 20 men. So then for dance, there's 18 people that like dance, 16 for sports, and TV for 16. Sometimes on your frequency tables, these total columns will not be there, and you'll have to come up with those by yourself. By analyzing a two-way frequency table, we can summarize and find trends. For example, if we looked only at the numbers in the total row, we might conclude that the 3 activities had roughly equal appeal. So I see the 18, the 16, and the 16 all are pretty close. Yet, looking at the non-totals, we see a strong preference for dance among women, so 2 compared to 16, and little interest for dance among men, so that would be the 2. By analyzing a two-way frequency table, we can summarize and find trends. For example, if we looked only at the numbers in the total row, we might conclude, that's from the other example, excuse me. Example 2, the table shows the type and outcome of matches played by a cricket team. So this is what the cricket player looks like. So notice how the total row is not there, so we should probably fill that in. So with my totals, I have 7 winners, 10 draws, and 9 losses. I have 13 away matches, 13 home matches, for a total of 26 total matches. So how many matches were played all together? That would be the 26. How many matches were lost altogether? How many matches in total were not drawn? So not drawn would be a win or a loss. So I'm doing 9 plus 7, which is 16. Here's a two-way frequency table that shows the audience at a movie theater. So we have children, adults, male, and female. Calculate the percentage for each of the following. Male children who were at the movie to all children. So we have 15 male children, all children is 38. For 39%. Number 2, female adults who were at the movie to all adults. So female adults is 30, all adults is 54. Work that on your calculator and you get 56%. Male adults who were at the movie, so that's 24, over all males for 39. And again, we're just rounding our percentages to the nearest percent. Female adults who were at the movie compared to all females, so that's 30 out of 53, for approximately 57%. Describe the trend from the data. I said more adults than females attended the movie. Try this one on your own. And here are my answers.